Okay, I'm going to take a look at problem 44 on page 427 from chapter 7. Okay, this one is you need to calculate wave steepness, right? And what you're going to do is you actually need to create this file. It's not given, but we can create one with a few values in there. But basically, you have a file of this structure: year, month, day, hour, minute, and then wave height, and then wave length. Okay, so we're going to go through and read this in from a file and calculate the average steepness right from that. And then we'll also look at determining the percentage of time the steepness exceeded the average. Okay, so uh, we need to be able to go through and calculate the average. So with that in mind, we could actually come up with an average without going through and using an array. But we need to be able to calculate that, calculate the percentage of time it's above an average. So we need to be able to have those values retained after we calculate the average. So we need to have a temporary storage for that. Okay. And it says file could be of any length. Okay, so we'll just maybe we'll create a few days just to see that it works, and we can go back and look at the section on tsunami warning systems to come up with a sample data file, and that's what I'll do. So what I'm going to do is just go to section 7.6, page 380, and I could just go in there and fill out some data. And I'm just going to use the data they gave here. I'll probably just put 5 rows in this. 1, 2, 3. Okay. So here's the year, month, day, hour, minute, and then here is the wave height. And the last piece of information we need to put in here, the length. Okay, so that's one more piece of information. So the last two is going to be wave height and length. So I'll use some of the information from the file. I'll go and type it in. I'll do just five rows, and then I'll just randomly select some values for wavelength. Okay, I just went through and created a file, tsunami.txt. It's not just on my desktop right now. I just took the first 7 rows from that on page 380, and then I just filled in 7 or 8 for the wavelength. It really could be anything you want. I just made it 7 or 8 because I think in the example they had 7. So we'll go with that. But it should work for any files. Okay, this is just sample data. So just save it. Okay, so I'll just go and start Visual Studio and create a project. New project, console app, next, and then it's going to be called, I need to make this my desktop. And then I'm just going to say chapter 7 problem 44. Problem 44. Create. Okay. Well, the first thing I can do is I can take my file, my tsunami.txt. So here's my project I just created. And the way mine is structured is that the source code is actually in this subfolder. So I'm just going to move this over here. And there it is. There's my text file. Okay. So now I put the text file in the same folder as the CPP file for that project. Okay. All right. So we'll just do, so since we're dealing with files, I know I'm going to need fstream. And I'm going to need my using namespace. std. I maximize this. Okay. I'll just delete this. Get rid of all this. Okay. So we know we need to do a return 0. I'll do a system pause here. And I'll just create a, so I need an input file stream object. And this is input. Well, I'll do this file input. Okay. Then I'm going to, well, I'll need to create different variables and probably some temporary variables because I only need the last two columns for this particular problem. So I'll create some variables here, and it looks like probably I'll make them all integers except the last two. I'll make those double data type. But the first let's see, 5 are going to be integer. So integer, I'll just say year, month, day, minute, hour, and those are the 5. Then I'm going to have wave height and then wavelength. Okay, so I'm going to do those double. Wave. In my case, I used integers for the wavelength, so but it should be able to support floating point numbers. Okay, then wave length. Okay. All right. The next thing I want to do is do a file open, right? So an open input. Have some choices here. I can actually create a string variable here. So why don't I do that? I'm going to create a string variable. I'm going to call this one string. And I'm going to say it's file name. Okay. So this allows the user to enter the file name. So I'm going to do that up here too. So you can see this. Include string. Okay. All right. So I can use a file name here. So that way I can prompt the user for the actual file name. So why don't I do that? I'll do cout. Enter the file name. Okay. cin file name. Okay. Now when I do a file input dot open, what I'm going to use is I'm going to do the file name dot c underscore str. Okay. And that is a method itself. Okay, so that'll return the method and actually open. It'll open whatever you entered for your file name here. It's going to use that, the name, to actually open that file. Okay. Now what we'll do is check to see that it opened correctly, right? File input dot fail. So if it fails, right, we want to display a message. This is the usual thing, right? We want to do cout error opening file. Okay. End line. And then we could do a return or an exit. Really doesn't matter. We want the program to end, right? I'll just do this. I could do a -1. We actually don't do anything with the actual value, but this returns this to it returns a -1 to the operating system. So you could actually log that error if you wanted to with the operating system. Okay. Okay. So that's that. And then we'll do a file input dot close at the end here. Okay. All right. So let's just run this one and make sure it opens the file correctly. If it opens the file correctly, then we'll start to work on reading the values in. So we run it. And it just enter the file name. So I think I called tsunami.txt. Okay, so it opened it correctly. All right, so it didn't give me an error. All right, so we're looking good there. All right, so now what we want to do is we want to read in essentially every row from the file. Okay, so I'll say while file input .eof. Of course, it's not. When it's not, as long as it's not, we haven't reached the end of the file, which means the end of file flag has been set. As long as it's not to the end of the file, we want to keep reading it in. Okay, so we're going to do cn, and we need to read in every value. So the year, month, day, hour, minute. Okay. Oh, is it minute, hour? I think it is hour, minute. Yeah, hour, minute. Okay. Okay. So I can keep going. I'll just do this wave. It fits in here, so I'll do wave height. You could do a separate line if you wanted to. So wave height, and then wave LENGTH. Okay. And if you want, what we could do here is we'll just do a C out, just to see that we read everything in correctly, right? Not incorrectly, but we read it in properly. I'm just going to copy, Control V. And, you could do a find and replace for all these. I'll just do them manually. They're not that many. Just C out. Okay. And that's that. Enter file name. Okay. Oh, just a mistake here. This should be file input, of course. Otherwise, it'd be prompting. This is prompting the user. Okay, so from the file, read it in, and then display it. So we're going to see if. I also put a system pause right here. Otherwise, when it fails to see the file, just close without stopping. Okay. All right. So let's run it, and we just want to see that it reads the file correctly and displays it. So tsunami. Okay, there it is. So there's no spaces in here. We could put them if we wanted to. If I wanted to put like tabs or spaces or something to show that this is so like, let's say, otherwise the numbers are all sort of blended together there. All concatenated and added to the end of the others. So just put a space to see these. Okay. Oh. So I'm just spacing them out, putting a space between each output. And one more here. And then I'll do an end line. Okay. Sorry, wrong place. Here. And then an end line. Here. Just squeeze this over a little. Oh, end line. Okay. So now let's run it. Let's see what we get. So tsunami.txt, tsunami.txt. Oh, tsunami. I didn't spell it right. Yeah, you could also hard code it in And then at the end, you make it a string. It'll actually save you a little time here. Okay, so there it is. So that looks good. Okay. So the next thing we need to do is we want to be able to read these values into a couple of arrays, okay? So these are just reading in the variables themselves. What I really want to do is make this an array, okay? And what I can make both of them arrays actually. I have 7 items in my file, but I don't know. You could make it 100, I'd say. It really doesn't matter as long as it's large enough. The author prompts it says that as part of the spec, you need to be able to support a file of any size. Well, we still have to kind of limit it, at least if we're using arrays to solve this problem. We didn't talk about vectors, but vectors is another way to do it. But we'll do it. We'll say that for this particular problem, we'll make it a size 100. So it's got to be, the file can only have 100 items in it, all right? So that limits the size, which is okay. All right. So the next thing I need to do is specify this and say, like these first, I don't even use these. So I'm just reading them into like temporary variables, year, month, day, hour, minute. But wave height, I'm reading this one into an array. So I'm going to put I there, and I'm going to put I here. I'm going to do the same thing here. I'm going to do I guess I'll just do this. I'll do I, and then I'll do I here, just to display them. Okay. So now what we need to specify is we need a variable, like a counter index or an index variable. So I'm just going to go up here, and I'm going to create I, and I'm going to say it's equal to 0 to start. Okay. So down here, after we do this, we need to increment it. So I plus plus. Okay. Now all I want to do is I want to run it again, and I want to see that it's reading it into these arrays correctly. Okay. So we'll do that. And if it gets displayed properly, then we know that it's reading it in correctly. So tsunami.txt. Okay. So we're looking good. And I've got 7 items. All right. So that looks good. All right. So the arrays are working correctly. Okay. So next thing I want to do is it's as part of the specification, and let me just, as part of the requirements, what we need to do is come up with an average. Okay. We can do this with a function, or we could do it. We calculate the average from a function if we wanted to, or we just do it a little bit later here. That's also fine. What I'll do is I'll create a function to do this. Okay. So I'm going to go up here, and I'm going to create the prototype for that function. And it's going to, I want it to give me the average. So I'll say double. I want to return a double data type, and I'll call my function average. And I want to pass in, I want to pass in both arrays. So I'll do a double. One array and double, because it's going to be the average of the steepness. Okay. And then the size. So we only need to put the size in once. So I'll just say size integer. I'll just do it like that. Okay. So now my function will be double average. And then I'm going to do double, and I'll do it as do double. I'll do WH for wave height. Oh, and I got to do square brackets because it's an array. Then I'll do double wavelength, and then I'll do integer size. Oh, and there's, okay, yeah, that's good. Integer size like that. That works. Okay. So inside, I'm going to create a loop, and it's going to be integer. I'll just use I again. It really doesn't matter what variable I use here. I can use, okay, I is a common one. I less than size. I want to make it 1 less, so we'll keep doing it. Keep looping through until the size I is 1 less than the size. and then I plus plus. Okay, so let's perform the calculation here. So the calculation here is we'll keep track of like steepness. So let me do this. I'll say total. Oh wait, double, and I'll say steepness sum. So I'll keep track of that. So I'm going to set it equal to 0. All right. So steepness sum is equal to whatever the steepness sum was before. And I'll just write it all out. I won't use any shortcuts here. Or an abbreviation. Plus WHI divided by WLI. Okay. So we're going to keep track. This is the sum. So we're keeping track of the total steepness. Okay. Then the average, what we want to do is return steepness sum divided by the count. Actually, I need to pass that in also. So let me just call it count. I also need to pass that in, right? Because this will return the average of those. But we also need to pass in, when we make a function call, we're going to pass in I. So okay. So let me do this also. I need one more integer. So this is the number of items in the array, right? Oh, you know what? I don't need that because the size is actually not going to be 100. It's going to be however many items, right? So we're good. Okay. So we're good. Not count. This is size. Okay. So this should be fine. All right. Now what we need to do. So this reads it all into the array. My next thing I want to do is I want to just do a cout. And I'm going to make a, so I'm going to say average steepness equals, and then I'm just going to put in here, this is where I make my function call, average, and then my two arrays, which is wave height, gets passed in, so just the name of it, then wave length, which also gets passed in, and then the size. Well, the size is actually kept track with I, right? So I can use I. That tells me how many items are read in, okay? So I'm going to use I, and then that's it. Okay. So I'll just do save all, and then if everything's good, here's where I calculate, here's my steepness total, or my steepness sum, right? This keeps track of all the steepness quantities as I go through it. Okay, so let's do this. Let's run it. And tsunami. And it says 0.205 or whatever. Okay. It doesn't say anything about how many. Let me do end line here. How many actual decimal places you need. What is this? I don't know what that is. Okay. Huh. 30 days, I guess, huh? For this thing. Okay. So I can sign in and unlock it. But I got a couple more days. All right. Okay. So that was the value given. So now let's do this. Let's just check our results. So tsunami nami.txt. Okay. So it says the average steepness is 0.205842. Okay. So let's check. Let's do let's see if we we make these a little bit different just to check my results. So let's make some simpler numbers in my data file. So let's do this. Let's do 1 over 5. And the second one, let's do 2 over 10. Okay? So I'm just going to try some numbers. I can leave those numbers in. It really doesn't matter. All I'm doing is checking my calculation. Okay? So 1 over 5 is going to be 0.2. 2 over 10 is going to be 0.2. So if I go in here and just make this 2, it's only going to calculate the steepness for these first two. Okay? So if it comes out to be 0.2, I can feel pretty good about that in terms of the average. Okay? So let's run it. And tsunami. And, 0.167, okay. Oh, you know what? I didn't save it. Hold on. Oh, I gotta save. Let me say save as. File, save as. Make sure it's in the right place. Oh, okay. So this is the wrong one I changed. So I've got to change the one that's in the actual project. So it's this problem right here. So it's in here. Okay, there it is. So I'm just going to overwrite that one. Yes. Okay, so let's run it again. So enter file name, txt, and there's my 0.2. Okay? So that looks pretty good. All right. Now what I want to do is I need to do one more. So that works for the average, okay? So what I'm going to do is I'm going to modify my file. Actually, I use these values. Now I'm thinking about modifying them a little bit better just to make it easier. So I'm going to say 1 over 10. I'm just going to put in two different numbers here. I'm going to do 2 over 10 and 1 over 10. And I'm only going to do these two because this will make it easier when I actually, and I can use any numbers afterwards, of course. Once I feel this is good, I can put whatever numbers I want. But there's a point to doing it like this. So what I want to do is I want to calculate the percentage of the these numbers that are, in this case, you want to determine print the percentage of time the steepness exceeded the average. Okay. So if I do 1/10 and 2/10 like this, I got 3 2/10, and so it's 0.1 or 0.2, right? So my expectation that when I run this, and I'm going to remove the 2 I have in there, is that I'm going to get an average that's between 1/10 and 2/10, okay? So let me do that. I'm going to go, and I'm just going to put this as I again, and I'm going to save it, and I'm going to run it. So let me expand it, because I'm just checking my results right now, right? And then I'm going to calculate the percentage of time it's above that. So tsunami.txt. Okay, 0.215. Right. Oh, okay, right. So it's between. Let me see. All right, I got to make sure I save as. Okay, save it. Yes. Okay. So now run it again. Okay. txt. Okay, so there it is. 0.147. So it was between 0.1 and 0.2. Okay. And since there's a little bit more, there's 4.1s and 3.2s, it's going to be less than 0.15. Okay, so that's what our expectation is. Okay, so the next thing is what we want to do is we want to find how many of these are the percentage of these that are over this average. So we're going to perform a calculation, and our expectation is with this data file, it's going to be 1, 2, 3, or 3 out of 7. Okay, so 3 out of 7 is going to 3 out of 7 are if you just do the calculation, what's that come out to be? 3 divided by 7 3 divided by 7. So our expectation, it's going to be 428, okay, approximately. 0.428, our result. So 3/7 or 0.428 out of 1, or 43% of the time, it's going to be over. Or 43% of the time, it was over the average, okay? So when we do the calculation, we can see that. All right. So the next thing we want to do is, now that we have the sum here, we actually need to use the array to perform that calculation also. All right. So what I'm going to do is I'm going to just go in here and I'll create it this. I'll call this percent over AVG. Okay. And the same thing. We need to pass in the arrays as before and the size. Okay. So then I'll just copy this and I'll create another function. So this is the percent over average part, and I'm creating another function to do this. So I'll do this right here. And you could check the author's solution, how the author went and solved it, but here's my solution. So you can compare and contrast those if you want. Okay, so now that's my over the average. All right, so the same thing. Now what I need to do is go through, I need to go through this. Control copy, go through each item. And this time, when we go through each item, and we can actually do this. We'll keep these. I'm going to do a comparison. Okay. So, oh, you know what I need to do? One more thing. Forgot. I'm going to do double. There are a couple things here. First thing I need to do is actually define these. This is wave height. This is wavelength. This is size. And the last one here is going to be AVG, because we need to pass in the average, right? And we're going to use it. So from here, I'm going to say if wave height I divided by wavelength I is greater than average, I'm going to increment a counter. Okay, I'm going to call my counter just over. So that tells me that's, and I'll do integer over. This just keeps track of how many times it's over. Oh, so it equals 0 over the average. All right. So then at the end, what we're going to do is we're going to return, and we're going to return over divided by size, right? So the number of the overs, how many of them were over, divided by the size, which is how many elements essentially were in there. And I need to do one more thing. I need to do a cast, double cast, right? Because it's an integer over an integer. It's integer division, right? It would be 0 if we didn't do that. Okay, so now it'll return that. All right. So the next thing I need to do here is I'm just going to do a cout percentage over average. All right. And now see, I calculated the average here, and I didn't put it in a variable. I actually am going to need to create a variable for that. Okay, so we'll do that right after this. Equals. And I'm just going to be percentage over average. Pass in wave height, comma. So these are the arrays. Wave length, the array, comma, and it's the same thing. It's I, except I'm going to do one more thing here. I'm going to say average value. Okay. So I'm going to create this other variable called average value, which I need because I have to use it here. So I'll do average value equals this thing. And then I'm going to put this just average value here. Okay. That way I'll use it down and I'll use it here also, right? Okay, and then I got to declare it. Okay, so I'm kind of doing things backwards, but you'll see. Average value. Okay. Now I'm going to go up here and put this in here, comma, average value. Okay. So that contains the average. That's a variable that contains the average value. All right. So that's when I use it here. So I calculate it, and then I display the average steepness, but then I need it when I calculate percentage over average. So I pass it into the percentage over average function. Let me see. Oh, I also need to add it here, right? Comma, double. Okay. I need it in my prototype. All right. So there's my prototypes. Here's my function call here. And then I'm going to display the average value. Then I'm going to pass the average value into this function, percentage over average. And there's one more part I need this, of course. I need to actually do this. I'm going to multiply times 100, right? Because it's a percentage. It's not a ratio, the result. Okay? So there's my percentage over average. There's my average function. Okay? And like I said before, our expectation this should be about 4.428 approximately for the data that I have. File name, tsunami.txt, and 0.428571. So that looks good. One more thing here. I'll just do an inline. Okay. And of course, you really don't need to display this. So I'm going to remove this. This is not part of the program. And if I run it, tsunami.txt, and there it is. There's the average steepness, 0.142857, and here's the percentage over the average. Okay, so that's pretty much it. This is, and I'll put this on the website so you can see, you know, my solution and how I did it step by step. I went through it all. Okay. Okay, and like I said, this program's a little different than what we previously did because we prompt the user for the file name. You could also put some information in here. Maybe you write out a message, do a cout that says like this file calculates, this program calculates like the average steepness and percentage of average steepness of tsunami waves, and maybe the percentage of or the average steepness of waves, and the percentage of the waves that are over the average. Okay. All right. So just checking the file, see if it's open. Then this one here just just reads values into the array. Okay. Then this, of course, calculates the average value. And then this one calculates the percentage, right? And that's being done in these two functions, right? Here's the percentage over average. Okay, here's my arrays. Here I are going through each element individually and making a comparison. If it's over, we increment this counter called over. And then over divided by the size times 100 gives us the percentage. And then here's the average function. Okay, so that is pretty much it. Like I said, I'll put it on the website in the source code area. So if you want to use it, check this one. And that's it for that.